So in this lecture we are going to see which factor will decide whether the unstable nucleus will go alpha decay, beta decay or gamma decay. Suppose this is a nucleus having number of protons and number of neutrons. Now if this nucleus is unstable, now what is the meaning of this instability? So this nucleus will have extra amount of energy than what is required for the stability of the nucleus. Let Q be the extra or the surplus amount of energy which is available with this nucleus. Now if this Q value is in the range of 4 to 9 MeV, so if this extra amount of energy is in this range, then this nucleus will go this alpha decay, and the Q value which we found here, it is in the range of the 4 to 9 MeV. Now how we measure this Q value? So whatever extra amount of energy is there, that is given out or that is carried out by this 2He4 nucleus, as this nucleus is very small as compared to the daughter heavy nucleus. Therefore by measuring the kinetic energy of this 2He4, we can measure the Q value of the alpha decay. Now if this nucleus is having a small amount of energy, say in the range of this 600 to 500 keV, then such nuclei will undergo the beta decay process. In this process, the proton to neutron ratio is also not which is required for the stable nuclei. So by converting one proton into the neutron or some neutron into the proton, it will go the beta decay process. The general trend is the daughter nuclei which is left out in alpha decay, it is generally radioactive. It will also have some surplus amount of energy, but this energy is not sufficient for the alpha decay. So such nuclei which are having the extra amount of energy in the range of this 600 keV, so they will give out the beta decay. So generally these nuclei which are left out in alpha decay and they are not having the extra amount of energy to give out the alpha decay, they will generally give out this beta decay process. In this beta decay process, the proton is converted into the neutron or neutron is converted into the proton. And again after this beta decay, whatever daughter nuclei is left here, it is also in an excited state and it may de-excite from the higher excited energy level to the lower excited energy level or to the ground state. So the nucleus is not changing, but it is just de-exciting from the higher energy level to the lower higher excited states to the lower excited state or to the ground state. And the energy available here, it is also generally in a 600 keV. So in the gamma radiations, nucleus is not changing. So the moral of the story is this Q value will decide whether the nucleus will go the alpha decay, beta decay or the gamma decay. If the surplus amount of energy is in the range of 4 to 9 MeV, it will go alpha decay or it will decay through the alpha radiations. If the energy is in the range of 600 keV, and if the neutron and proton ratio is not balanced, which is required for the stable nuclei, it will decay through the beta radiation. And if nucleus is having the extra amount of energy, it is in the excited state, it will de-excite by the gamma radiations.